Hi, my name is Darasha Brown, and this is my Lab 2 report. The purpose of this lab was to explore the electric force interactions between charged objects and calculate the electric force on charged tapes when the charge is distributed evenly, and then to create a virtual program modeling this interaction. And the models used here were two pieces of standard Scotch tape and a computational VPython model to calculate the charge for a single piece of tape. The key principles used throughout this lab were Newton's second law, or the law of static equilibrium, where the net force is equivalent to the change in momentum divided by the change in time. The force of gravity is calculated as negative mg. The electric force is the charge times the electric field. And we have two formulas here for the electric field. So the first is for a point charge, and the second is for a uniformly distributed rod. And a brief result preview, we have the force of gravity and the electric force that ended up being shown by the computational model, as well as the charge, and we'll go more in depth about these results later. So the system for this was tape B, or the higher tape, and the surroundings were the earth, the other tape A, and the air. The initial conditions were that tape B was rested flat and it did not float due to the lack of a charged object nearby. The key assumptions needed for this lab is first that we ignore air resistance, and secondly, we assume that each tape has the same amount of evenly distributed charge. The process of this lab, taken from the first lab, was to take two pieces of tape and charge them, and then we used tape B attached to two books to suspend it horizontally, and as we brought tape A closer to tape B, we would measure the distance between when the tape started to float. And then we use the length to find the mass, as well as calculating eventually the force of gravity and the electric force using the aforementioned formulas, and the charge of the tape was calculated as well. Here's the code that represents all of the work we just did. So here you can see that this shows how we get our point charges, as well as our electric force, our force of gravity, and then this just works through the rest of the calculations provided in the starter code. And then this is what we end up with the model with our VPython. So the white arrow is the electric force, the yellow arrow is the force of gravity, and then you have your red circles, which represent the charge on tape B, the blue is the charge on tape A, and then the green arrows represent the electric field from the blue tape onto the red tape. So coming back to these results, we see that the electric force and the force of gravity have different magnitudes here, but in the model, they have the same arrow length. And then the charge was calculated to be 2.94 times 10 to the negative 8 coulombs. So like I just said, the differences in the magnitudes of force of gravity and electric force were very interesting considering they had the same length. And some possible sources of error could be that we did not account for air resistance. The distance between the tapes was estimated by hand, and that the ruler used for the differences only measures to millimeters, so that didn't have a high degree of accuracy when we're looking at charges and things that are in 10 to the negative 8th or the negative 19th. So what if we had modeled each of these tapes as a single point charge like in lab 1? Then the values for the electric force and the charge would change, but the force of gravity would be the same because the mass would not change. So comparing these values, the point charge, we got 1.66 times 10 to the negative 8th coulombs, while the line charge was 2.94 times 10 to the negative 8th. So the line charge was 1.77 times as large as the point charge. And why do these estimates differ? Because the geometry of the objects matter, and as we can see by the different formulas, the distribution of charges affects the orientation and magnitude, and the line charge would be more accurate because a piece of tape is more close to a rectangular rod than a single point. So in conclusion, the Scotch tape is better modeled as a line charge than a point charge, and this lab shows how household objects can be used to explore science. Thank you.